So as a refresher, I want you to go through these examples right here. This is just when you have equations and you're trying to use your knowledge of exponents to get the same base on both sides of the equation. So go on and work on these 5 problems and come back and check your answers. Okay, take a moment to check your answers. If you need to pause the video to take a little bit more time to do that, please do so. But we are going to continue on, and I want us to remember the equation for continuous compound interest, which is just A equals P, which is the principal, times E raised to the RT power. And so what I want to do is take a look at this and look at a particular situation. So here they're saying, how long would it take to turn $1,000 into $2,000? So our initial investment is $1,000. We're trying to make or earn a total of $2,000. They tell us our interest rate, and they tell us it's compounded continuously. So if I put this into an equation, we have 2,000 equals 1,000 times e to the 0.02 times t. And if we were trying to solve for t, the first thing we would do, right, is just divide by 1,000. And so we're going to end up getting 2 equals e to the 0.02 t. Now, we've never actually seen a variable in an exponent like this, and we don't know how to solve this. And what I would say is we are going to learn how to solve for t, and we're going to start with that, with the building blocks today, and we're going to continue through the chapter to learn how to solve for a variable when it is in an exponent. So this is where we introduce a logarithm. So a logarithm helps us to solve when you have an equation where you have your variable in the exponent. So like this equation right here, 2 to the x power equals 12. So I want you to know that a logarithm, and it is abbreviated just with log, a log is used when you are trying to solve or when you are solving for an exponent. So let's take this a step further. I want you to know that when we have this equation 2 to the x equals 12, we can write it as a log expression. And this is read as log base 2 of 12. It's really important that you get that wording down because it will help you as you go on. So this is log base 2 of 12. And what I want you to remember here is that when we say log base 2 of 12, really what I want you to be asking yourself is 2 to what power equals 12? Now you may be wondering, Miss Elrod, there's not 2 to some integer that equals 12, and you're right. If we were going to have to solve that, we would have to use our calculator. We'll learn about that more in another class. But today I want to look at some logs that we can figure out. We can determine what they equal and evaluate them. So here I want to ask yourself, 2 to what power equals 16? And hopefully you're thinking 4, because we know 2 to the 4th power equals 16. And for each one of these 10, I want you to ask yourself, like in this case, 3 to what power equals 81? So 3 to what power equals 81? And hopefully you came up with 4. So I want you to go through the rest of these through number 10, and I want you to see if you can figure out, again, ask yourself, just like we did number 2, 3 to what power equals 81? And you know that's 4. So go on and finish the rest of them, and you can come back and check your answers. Now, hopefully you were able to go through all of these. I would take a moment to take a look here. I do want to point out a couple. 5 to what power equals 1, and anything raised to the 0 power is always going to equal 1. Also on number 8 and, on 7 and 8, you notice that 2 to what power equals 1/2, and that's going to be 2 to the negative 1 power. So you want to look out for those negative exponents there. Okay, so we've introduced the word log and logarithm, and I want to talk about how you can go back and forth between exponential form and log form. So exponential form, if you remember, our basic exponential function is just b to the x equals y. And I want to talk about how we can take this log form and turn it into a logarithm. Now, hopefully everybody understands that b here is the base of our exponent. And I'm just going to write log right here. The base of our exponent is going to become the base of our log. And I'm going to highlight these in the same color. In this case, I'm going to highlight them both in yellow. So the base of our exponent becomes the base for our log. We reach across the exponential equation and grab that y. So we reach across the equation and grab that y. And then it's just going to equal our power. So it equals our power here. We reach across the equation and grab that power, which is just x. So I'll highlight all of these so you can see where they are coming from. The other thing that I want to just point out to the side, so b is going to be the base of your exponent, and it also is the base of your log. And y, I will refer to this many times as the argument of the log. And again, when we see a log equation, it says the log base b of y equals x. That's how you would read that equation. So let's go through an example here of what this looks like. If we end up having 10 to the x equals 85, we want to take that basic exponential equation and write it in log form. So we would say log, and our base of our exponent becomes the base of our log, and we reach across the equation to grab our argument. So log base 10 of 85 is going to equal whatever our power is, which is x. Okay, so this is a little image to show you what we have done. What we did, we took the base of our log, right, and it becomes the base of our exponent. We reach across the equation. We're reaching across the log equation to get our power, and then we come back and pull our argument, and it goes down right here. I had a student last year who said, Miss Elrod, this is just like Roman numeral 9. And I had no idea what she was talking about, but I'll share this with you in case it is helpful to you. So if you take log base b of x equals y. Here, I'll do it like, well, maybe I'll do, that's fine. We'll leave it all. Log base b of x equals y. So we know that that becomes b to the y power equals x, right? So what she said was that you pull down, so there's your 1, you pull down your base of the log becomes your base of your exponent. What's on the other side of your equal sign becomes the power of our exponent, and then the argument of the log becomes what it's equal to in our exponential. And you'll see here that what I have written in pink looks like the Roman numeral 9. So if that's more helpful to you to help memorize how to go back and forth between logs and exponents, absolutely use that. Okay, so let's go through some examples here of switching back and forth between exponential and log form, and then also pulling in solving for x. So if we have an exponential form that is 4 to the x equals 16, if we change that into the log form, it would be log base 4, I reach across the equation, log base 4 of 16 equals x. And remember when we talked about the very beginning of the day, we said 4 to what power equals 16, which is really an exponential equation. And we know here that x is going to be 2. So in this next one, we're actually taking a log equation and making it into an exponential equation. Remember, our base of our log becomes the base of our exponent. We reach across the equation to get our power, so 2 to the x is going to be equal to whatever our argument is, which is 32. And 2 to the x power equals 32, x has to be 5. Now let's look at the next one. So the next one, we have 27 to the x equals 81. And here, if we're going to write this in log form, it would be log, and my base of my exponent becomes the base of my log. So log base 27, we reach across the equation of 81 is going to equal x. And if we wanted to evaluate this, really we go back to our exponential equation. So we have 27 to the x equals 81. And we can't solve that as is. We've got to get a same base. So we've got a base of 3. So we have 3 to the 3x equals 3 to the 4th power. 3x equals 4, so x is going to be 4/3. So I want you all to take a moment and work through these remaining ones and then come back and check your answers. Okay, so a couple of things I want to point out as you are checking through your answers right here. I want to point out that on this last one, when you end up having the exponential equation 64 to the x power equals 2, remember that is 2 to the first power. So make sure that you remember that as you are solving and setting your powers equal to each other. Okay, so the next thing I want to talk about is some common bases that we use. So here, when we have a log function that has a base of 10, that is called the common logarithmic function or the common log function. And so many times when we have a base of 10, instead of writing it out log base 10 of x, we will just write log of x. And in this case, this is understood that it has a base of 10, Now the other understood type base is if we have a base e. Remember we talked about the irrational number e last class. And when we have a base e, this is called the natural log or natural logarithmic function. Now the natural log is written with an ln. So many times I'll use kind of a little cursive L to help me, but it's ln for natural log. And you'll notice that we could write a log with a base e. We could say log, right? Log log base e of x. Or if we just put natural log of x, this is understood that it has a base of e. So right here, we just have a few problems for you to go through. Again, no base is specified in any of these, but they're either going, because no base is specified, you either have a base of 10 or a base of e. So why don't you go through and work these problems and then come back and check your answer. Okay, so I first want to focus on this first one because what we're really doing is taking this equation and changing it into exponential form. So here, because this is log of 10,000 and a base is not specified, we know that it has an understood base of 10. And when we change that to exponential form, it's going to be 10 to the x power equals 10,000. And then we can just rewrite 10,000 as 10 to some power. And as a hint, the power of 10 is going to be however many zeros are shown, so 10 to the fourth power. And so I've got the other ones written here. So again, you're going to want to take your base of your log or natural log and help you write an exponential equation and then solve for x. So check your work, pause it if you need to, and let's come back down to this bottom part. So this bottom part is really just putting everything together, whether you've got a base of some number or a variable or a base of 10 or e. It's really taking these log equations, changing them into exponential form, and then solving for the variable. So I want you to go on and work through these practice problems, and then you can come back and check your answers. Okay, I've got the answers for all these problems. I hope that you were able to go through them. Again, remember when you have, like here we had 5 to the negative 2x equals 5 to the first power. Remember, if you just have a 5, it's always raised to the first power. And then I wanted to also point out when we have the square root of 2, remember that's the same thing as 2 to the 1/2 power. So you can check your work and check your answers against what I have right here to help you as you go forward. Homework is posted in Schoology for you to do.